It's Math 112, section 2.1, problem 36 on average rates of change. 36 gives us a graph with Q1, Q2, Q3, and Q4, and asks us to plot the secants, basically the slopes from a point Q to point P, as this lunar landing module is going to the surface of the moon. So you can see that according to the graph that it's falling faster. So in the beginning it takes it 5 seconds to travel 1/4 the distance down. By the end it takes the next 5 seconds to travel the 3/4 the distance down. So we want to estimate the slopes for each secant line. So first let's try to figure out what each of these points look like. Q1 looks like it's 520. That one's pretty clear. Q2 looks like it is 7. A little bit below 40, so let's say 39. Q3 looks like it's halfway between 8 and 9. So let's call it 8.5. And it's partway between 50 and 60, but a little bit more to 60 than 50. So not more than halfway across. So let's call it 58. Q4, it's halfway between 9 and 10, 9.5. And then a little slightly over 70. Let's call it 72. And then point P is definitely at 1080. So with this data points, we should be able to plot the rest of them. So we have 1, 2, 3, 4. Those are 4 secant plots. Actually, let's skip a line, make them wider. 1, 2, 3, and 4. Number 1 then will be 80 minus 20 divided by 10 minus 5, which is equal to 60 all over 5, or 12 meters per second. Secant line 2 will be 80 minus 39 all over 10 minus 7, that's this point right here, is equal to 41 all over 3 seconds will be 13.7 meters per second. And just as expected, it is speeding up. Q3 will be here, and it's gonna be 80 minus 58 all over 10 minus 8.5, giving us 22 all over 1.5 seconds, which is equal to 14.7 meters per second. And then the last one, which is the one that will actually use, this is part A, we'll actually use it to answer part B, because this is the closest distance to the surface that we have. 72 all over 10 minus 9.5, which is equal to 8 all over 0.5 seconds, which is equal to 16 meters per second. And this is how fast it was going when it hit the surface, as far as we can guess, 16 meters per second. And that's it.